So already it is given that this denotes the greatest integer less than equal to x. So we have to show it is discontinuous at all integral points. So we can let a be any integral point. At this point, we will check the left hand limit and right hand limit. And just as I told you, a minus h that we have seen in the previous part, a minus h is a minus 1, how I told you, and a plus h will be equal to a. Okay, so we will find the left hand limit first. Limit x tending to a negative fx, and x is replaced by, or you can write first definition of function, that is x minus greatest integer x. Then x is replaced by a minus h. So this will become a minus h minus greatest integer of a minus h. Okay. Now, as I told you, a minus h is equal to h tending to 0, h tending to 0, a minus h minus this will be equal to a minus 1. So we get limit h tending to 0, a minus h minus a plus 1, and a already cancelled, and put value of h, we get answer 1, left hand limit. Right hand limit, similarly right hand limit x tending to a plus fx. So I will write directly limit h tending to 0, and it is replaced by a plus h minus greatest integer of a plus h. So limit h tending to 0, a plus h, and a plus h will be equal to a, so minus a cancel h, 0, so we get 0. So left hand limit is not equal to right hand limit. Therefore, function gx. Here gx is given, so this f is replaced by g. Wherever I put f, just you can replace by gx. So gx is discontinuous discontinuous at all integral points. Check the continuity of this function at x is equal to pi. So similarly, we will find left hand limit, right hand limit, and some formulas for trigonometry will be used. So function is fx is equal to x square minus sin x plus 5. We have to check the continuity at x is equal to pi. Okay, so we will find first left hand limit. So limit h tending to 0, and we have to find at pi, so pi minus h replaced by pi minus h whole square minus sine x is replaced by pi minus h. Now I am replacing directly instead of writing. Now you can do it because we have done many questions now. So limit h tending to pi minus, we should solve, then put the value of h always. So this will be h square minus 2 pi h, pi square minus 2 pi h plus pi square. Sine 180 minus theta, do you know? Second quadrant 180 minus theta, all positive, sine is positive. So sine 180 minus theta, sine theta. So this will become sine h plus 5. Now you can put the value of h as 0. So this will become 0, this will become 0, and sine 0 is 0. You should show actually in examination like 2 pi h is equal to 0. You are putting plus h square means this is also 0, minus sine 0 degree 0, and plus 5. So we get only pi square plus 5 left hand limit. Similarly, go for calculating right hand limit. Then limit h tending to 0, pi plus h whole square minus sine pi plus h plus 5. Okay. So here, similarly, we have to solve the first bracket whole square. So pi square plus 2 pi h plus h square 180 plus theta. Now here it will be negative. So minus sine h plus 5. But sine minus plus, but sine 0 degree is 0. So this will also give you the answer pi square plus 5. Now find the value of pi. So f pi, value of function at pi will be equal to pi square minus sine pi plus 5, sine 180 degree. So sine 180 degree is also 0. So that's why we get again pi square plus 5. Okay. So we got left hand limit is equal to right hand limit is equal to value of the function. You can say that left hand limit is equal to right hand limit is equal to value of the function at pi. Hence f(x) is continuous at f(x) is continuous at x is equal to pi. Main problem is we have given the function and sine and cos, and their values are, means their graph is opposite to each other, as you know. Sine 0 degree 0, and then sine 90 degree will be 0. Sine 0 degree 0, sine 91. So cos 90 will be 0. So opposite of that, the graph will go in the opposite direction. So we have to convert. It is necessary to check the continuity. This function, I'll take first part first. We have to convert into one trigonometric function, otherwise we cannot find out its continuity, cannot check its continuity. We have to discuss the continuity, means check the continuity, whether it is continuous or not. Okay. For that, what we have to do, actually under root 2, you have to multiply and divide by under root 2 to make one formula of sine. How you can see that, if you will divide, suppose under root 2, multiply and divide it by under root 2, so that division will go inside. So it can be written with 1 by root 2 sine x plus, and what I am doing, I am dividing and multiplying by under root 2. Okay, this under root 2 is taken inside. So under root 2 cos x, like this. Now sin A cos B plus cos A sin B. Why I have taken under root 2? Because sin 45 cos 45 both are same at 1 by root 2. So 1 by root 2 can be written as cos 45 as well as sin 45. So this you convert into cos. So we can write cos 45 degree. 45 means pi by 4 plus cos x. First you write cos x and this can be written as sin 45 degree. Pi by 4. Why I am writing like this? Because you know that sin A cos B, you remember class 11 formula, sin A cos B plus cos A sin B. You can see this is left side, sin cos both are there, and right hand side you will get only sin A plus B. So only in this way we can convert into one single trigonometrical ratios. Trigonometrical ratio, then we can see its continuity. So that's why we have converted. Now this is sin x plus pi by 445 degrees. This modification you have to do in the given function. Now at x is equal to a, at x is equal to a, we will a be any point. We will take a as any real number, and at a we will find left hand limit and right hand limit. So at x is equal to a, where a is any real number. Let us suppose a real number r, that at that point we will check the continuity. If it is continuous at that point, that means it will continue at all the points. To take left hand limit at which point? A. So we can find the left hand limit x tending to a negative, and now we will use the definition root 2 sin x plus pi by 4. And root 2 is constant. You want, you can take it out, and limit h tending to 0 sin x is replaced by a minus h plus pi by 4 plus pi by 4. Okay. Then a plus h, we can write this in the way root 2 limit h tending to 0 sin a plus, this is limit, a plus pi by 4 should be written together, and minus h, and minus h. Okay. A plus pi by 4 minus h. With h tending to 0 sin a plus h, a plus pi by 4 minus h, like this. So then it will become, I'll write here clearly, we can write root 2 root 2 root 2 limit h tending to 0 sin a plus h written together and remove this. Sin a plus pi by 4 written together and minus h. Now you can use sin a plus b. Sin a, this is a and this h will be b. Okay. So sin a plus b, sin a minus b form. Sin a minus b, sin a cos b minus cos a sin b. So this will become root 2 limit h tending to 0 sin a cos b, sin a plus h, sin a plus pi by 4, sin a cos b means cos h minus cos a, that is cos a plus pi by 4 and sin h. Then put the value of h 0. So cos 0 degree is 1 and sin 0 degree is 0. So this will become 1. So we get root 2 sin a plus pi by 4 into cos 0 degree is 1 minus cos a plus pi by 4 into sin 0 degree is 0. So this will become 0, this whole part. Only this will be left. So we get left hand limit as root 2 sin a plus pi by 4. This is our left hand. Okay. Similarly, find out right hand limit. So for finding the right hand limit, same thing. We will write right hand limit is equal to, this is replaced by a plus h. So root 2 limit h tending to 0 sin a plus h plus pi by 4. And a plus pi by 4 again to write together, limit h tending to 0, and this you will make a. So a plus pi by 4 is will be a and h will be b. So a plus b sin a plus b. This is your a, the formula, and this is your h is b. This is h. Okay. So sin a plus b, sin a cos b plus cos a sin b. So under root 2 limit h tending to 0 sin a cos b. So sin a plus pi by 4 into cos h plus cos a plus pi by 4 into sin h. Then we get cos 0 degree 1 and sin 0 degree is 0. So this will become 0 and we get again the same value root 2 sin a plus pi by 4. This is left hand limit, right hand limit. Now value of the function. So fx, we have reduced fx to under root 2 into sin x plus pi by 4. Find the value at a. So if you put a here, you will also get the same value sin a plus pi by 4. So at every real point, this is having left hand limit is equal to right hand limit is equal to value of the function at point a, where a belongs to any real. Therefore, fx is continuous at all points. fx is continuous at all at all points. So now we will do the product. So in the product we will multiply divide by 2 and 2 sine theta cos theta is equal to sine 2 theta. Formula which I use here is 2 sine theta cos theta is equal to sine 2 theta. So this formula is used, we get this one. Finding left hand limit a x is replaced by a minus h, multiply 2 and use sin a minus b, sin a cos b minus cos a sin b. Similarly here sin a cos b plus cos a sin b and substitute the values. So sin 0 is 0, here sin 0 is 0, so it will become 0, cos 0 is 1. So we get only sin a and value of the function is also this. Therefore it is continuous at this point. So that's all this lecture. So next time maybe we have to take more questions on continuity and then differentiability will start, then differentiation, and that's very important for calculus.